so good in BGP? Why everyone is talking about this routing protocol only over internet?
Backbone of the internet can handle maybe millions of routes, right?
How many routes are there, by the way, in the current global routing table?
Not sure about it.
But more than 1 million. Even if you will check the global BGP table, you will find 1 million plus prefixes, 1 million plus routes in the global BGP table. Yes. So why? What is so good in BGP? Like why not we are using OSPF or EIGRP? The BGP
Because it support a different AS.
different AS. So between the AS we can configure IGP as well. After that redistribution, OSPF1, OSPF2 or OSPF EIGRP and then redistribution. Yes, na? You can configure redistribution. But you can say, Praful, there is some disadvantage with redistribution, as we had discussed earlier as well, that in the redistribution there is chance of loop. If we are going to perform redistribution, let's say in OSPF, in both the direction there is chance of loop, right? The large size of table, that is again another issue of redistribution. The database size can be increased, right? So okay, we can not configure lots of redistribution. Few redistribution is fine, it will work. Okay, that is one reason. Between the AS, not every time redistribution is the suitable option route, or it is not acceptable even. You will be not allowed to configure lots of redistribution. That is one reason. Another reason, why do we say BGP is the backbone of internet? Why we are only using BGP on the internet, not inside the company network? If BGP is so good, if BGP has so many good features, then why we are using OSPF or EIGRP inside the company network? Why we are not using BGP only everywhere inside the company network as well? So even engineer need to learn only one routing protocol. That is sufficient. But inside the company, OSPF. Between the company, BGP. Why so?
BGP is reliable, but it's slow compared to IGP.
BGP is reliable, but BGP is the slow, OSPF is the fast.
OSPF is the fast.
Okay. So, okay, when we need reliability or stability, BGP is more stable than all other routing protocols. When stability comes in picture, when it is required, is stability not required inside the company network? Is it like that? Is stability or reliability not required inside the company network, inside the organization network? That's why we are using OSPF. Both are equally important, speed as well as stability, reliability. So, okay, OSPF is fast, BGP is slow, but OSPF is less reliable than BGP. So why we cannot compromise with speed and let's use BGP only? Because other benefit is I don't need dedicated engineer for both the routing protocols. If my employee has knowledge, good knowledge of BGP, that is sufficient, because inside and outside, everywhere only BGP routing protocol is running. Yeah, so right now I have checked on the internet, 1.6 millions prefixes are there in global BGP table right now based on today's data. And internet is getting complex, you already know this, right? Every day new users are joining the internet, new prefixes are getting added, right? IPv4 or IPv6 route, but getting added. Anything else based on your existing knowledge or based on your IGP protocols learning? Because till now we have mastered all the IGP protocol. Before IGP protocol, even a static route, right? Now I'm assuming you are good enough with OSPF routing protocol. And based on that, can you tell me any other advantage of using BGP or the reason why companies are using BGP? See, one thing is very clear. Like, first think of internet. Think of internet. Billions of companies are connected to internet, like companies, ISPs, data centers, cloud providers. Each company has networks, their own networks, and they all are connected globally. So inside their own network, they are using IGP protocol. We are very clear and crystal with that, right? And that protocol is, most of the time, that protocol is OSPF routing protocol. But between the companies, companies network, ISP, data center, cloud provider, who will manage the routing? Your BGP routing protocol. Your BGP routing protocol is going to manage the routing between all the companies network, ISPs network, between data centers, between cloud providers, or between cloud provider or company, right? ABC company, XYZ company, Amazon, Google. All the companies network are also reachable with each other, right? Maybe I am employee of XYZ company, but is still able to access Amazon website. So XYZ company network and Amazon network both are connected. They are able to exchange the information and resources. So BGP is handling that routes. And here, when it's come to manage routing between the companies, between the ISP, between the data center, between the cloud provider of multiple companies, that means we have huge number of routes. Here a stable routing protocol is required. Here your OSPF will not work. See, if I will use OSPF, just assume you are a network engineer in a company and users are complaining that, let's say, I'm not able to access Amazon or Google. Your primary ISP was Airtel, right? Internet is getting dropped for 5 seconds. Will you change the route of Amazon or Google via ISP to via, let's say, Geo for 5 seconds? Or even a small link flap, right? A small link flap on Airtel router, right, which is my ISP, can break the OSPF neighborship, yes or no? If link will flap, then OSPF neighborship is also going to flap. All IGP routing protocol neighborship is going to flap. That means what? That is the meaning of stability. That means my IGP protocols, whether it is OSPF, EAGRP, or any IGP protocol, are not stable. Here we need a protocol who should first understand that really here I need to flap the neighborship. Is it the small link flap, or yes, there is a outage, link goes down. Between two routers, if I have lakhs of prefixes, and then if neighborship is flapping, breaking, it can be lost for companies. Exchanging 100 routes is different. Exchanging lakhs of routes is different. When we are exchanging lakhs of routes between two routers, we will not allow our routing protocols to recalculate the routing table like OSPF. OSPF always recalculate SPF and select the best path. Here we don't want our routing protocols to recalculate routing table again and again, even when there is a small link flap. on the internet, we need only a stable protocol, right? In distance vector routing protocol, what we have learned? Distance routing protocol select best path based on distance. Shortest distance will be always best. Then what I have told you, this is not the good behavior. Sometimes long distance can be also the best path. Similarly, in OSPF, we have understood OSPF calculate best path on the basis of bandwidth. Right? Cost. Cost is what? Reference bandwidth upon bandwidth of link. Now what I am saying, even speed is not sufficient to find, or bandwidth of link is not sufficient to find the best path or to calculate the best path, because sometimes we need a stable protocol, reliable protocol, and BGP is your fully reliable protocol. Actually BGP uses TCP protocol. BGP is an application layer protocol which uses TCP at transport layer, and all of you already know that TCP is the reliable protocol, right? There is acknowledgement. For reliability in OSPF we are using what? Acknowledgement message. In EIGRP also we are using what? Acknowledgement message. But those are tier 3 protocols, not fully reliable. But as BGP uses TCP, BGP is fully reliable. So who will manage the routing between the company network, between the ISPs, between the data centers? BGP. Then BGP comes in. And BGP is more than routing protocols. Like BGP is not going to select best path based on bandwidth, because here see, I have two ISP, right? I have two transport to reach my data center. One is via Airtel, one is via Jio. Maybe both the ISP has same bandwidth. Speed of WAN link is same. So BGP uses attributes to calculate best path. See, in EIGRP, how many ways we have for path manipulation? You can configure offset list. Yes, you can configure offset list. You can manipulate bandwidth and delay of interface. Yes, you can manage that. You can configure route filtering, summarization. That's it. Hardly 3 to 4, 5. In OSPF, again we can manage the cost. We can configure maximum LSA. We can change the metric type. Metric 3, 4, 5. That's it. BGP has 11 attributes to select best path. And out of these 11 attributes, you will learn the attributes like ES path, which is not going to check bandwidth. SP doesn't matter. How far your network is from the source. How many ES number, autonomous system between source and destination. That will decide the best path. BGP is the path vector routing protocol. BGP is going to select best path, not best. All IGP routing protocols works between connected router. If R1 and R2 are connected with each other, then your OSPF will work. Isn't it? BGP is the path vector routing protocol. Over the path we can configure my skin visible. Many more things we will talk about these all one by one about the BGP. My skin visible?
Yes, sir.
1 minute.
Yes.
OSPF, we had seen area concept that was so important topic of OSPF routing protocol, right? If I will talk about the real-time example, OSPF area concept, then there was some area to filter the LSAs, right? There was many other concepts: forwarder address, LSA 7, LSA 5, 4, 3, 1, DR, BDR. Similarly, we need to learn and master BGP routing protocol now, right? From today, I will request you all to perform lab of BGP. If you couldn't configure any lab of OSPF, just leave it for now. After BGP or after the routing module, I will give you the time, sometime here you can cover your pending OSPF lab. But from the today, let's focus on new routing protocol. Forget OSPF now, right? But see, OSPF is still required. Let's suppose here I have one network, two buildings are there in my company, building 1, building 2, and let's say 2 ISP are there, or 2 gateway for my company network, like this. There is connectivity R1, or you can assume 4 buildings simply, right? That's why I have 4 routers, or you can assume 4 sites as well, right? Connected over VPN, through VPN, our public network, R4. And here we have service provider, let's say, or let's suppose in this topology only, here on router number 1 I have one loopback 1.1.1.1, which is the router ID, and here 4.4.4.4. I want to exchange 1000 prefixes between router 1 and router 4. 1000 prefixes, 1000 prefixes between router 1 and router 4, right? Or let's say router 4 want to advertise these 1000 prefixes to R1 directly without advertising to R3 and R2, without advertising it to R3 and R2. Is it possible to advertise 1000 prefixes from R4 to R1 through any IGP protocol? Is it possible?
No.
Through BGP, is it possible? Yes. Through BGP it is
Yes.
possible, you will learn. But you have to configure BGP neighborship between router 1 and router number 4. And you can only configure BGP neighborship between router 1 and router 4 if there is reachability, if 1 and 4 are reachable with each other. So again, for the reachability, we need to configure what? IGP protocol. And again, my IGP protocol is going to be OSPF.
OSPF.
And then when we have reachability, I can configure what? Yeah.
BGP.
So BGP is going to work like a overlay. Overlay is nothing but the network, virtual network, which is running on top of physical network. I can even make it more simple. Assume like there are 3 routers, R1, R2, and R3. And I need to exchange some prefixes between R1 and R3, right? My router 2 is not capable to handle 1000 prefixes in the routing table, right? Like router 2 is the simple configuration router. Router 1 and router 3 are the edge router, high configuration routers. High configuration router, right? So router 1 has 1000 prefixes. I want to advertise it to R3. If I will advertise these 1000 prefixes in IGP protocol, any IGP protocol is running between router 1 and router 3, right? 1.1, 2.2, and 3.3.3. Any IGP routing protocol is running. Let's suppose OSPF is running. If I will advertise these 1000 prefixes in OSPF on router number 1, then router 2 is also going to learn it, right? But I don't want that. I don't want that. And this particular network which you are able to see right now is your physical underlay, right? So what you can do, you can configure BGP session like your tunnel, like overlay between 1.1.1 and 3.3.3. But it will only work if there is reachability. This is going to be your BGP session, and through BGP session we will advertise my 1000, 1000. So simple, like this, right? So router number 2 will not have these 1000 prefixes. Router 1 will directly advertise it to router number 3. So BGP can work with connected or not connected device. If there is IP reachability, you can configure the BGP. Doesn't matter which vendor device R2 is or which routing protocol is running. Let's suppose R1 is the Cisco router. R3 is also my Cisco router, high configuration router, and R2 is one normal configuration router, let's say HP router or Aruba router, right? A simple Juniper router, any router. If there is reachability between two Cisco router R1 and R3, you can configure the BGP. It is going to work like a tunnel overlay. And again, here I can have one more path between router 1 and router 3. That is what? That is internal reachability. Doesn't matter how many paths are there between router 1 and router 3. But you will have only one BGP session. We have only one BGP session. Right guys? Like in the GRE. In the GRE, if I have, let's say, two sides. Side 1 and side 2. In between, internet is there, and our internet, you know, lots of path is there between side 1 and side 2, lots of routers are there. But when we will configure the tunnel between side 1 and side 2, we will have only one tunnel, correct? And until and unless any one path is active, is running fine, my tunnel will be up. It is like that, right? Don't worry, we will learn these all things in the BGP class. Just I am trying to make you understand what that here in these kinds of scenario you cannot configure IGP, or you can't achieve your requirement, your needs with the help of IGP protocol. You have to configure BGP only, right? BGP is the internet routing protocol which connects different companies, customer, ISP, data center networks together. So let's start with the basic introduction, and I will come on the why part. Today I will talk more about why BGP. BGP stands for BGP stands for
Border.
Border Gateway Protocol. First of all, it is open standard protocol, means we can configure BGP on any vendor devices. Open
Devices.
standard. Second thing is it is BGP protocol. Till now, whatever protocol we have learned, that is, those are
Interior.
IGB.
IGP, interior, and BGP is the EGP. BGP can act as a IGP as well, right? You can say BGP is IGP plus EGP, both can works within the AS and between the AS, right? In within the AS, you will see like full mesh is the very common scenario, very common and very important, right? We will discuss that. But the meaning of EGP is clear to everyone. What is the meaning of EGP? Is it clear to everyone?
Yes.
Yes, bro. Yes, sir.
BGP means exterior gateway protocol, means it can work with between the autonomous system number. Like in case of IGP, between the AS you have to configure redistribution. Without redistribution, IGP protocol will not work between the autonomous system number. Right? I had told you the routing domain or routing policy is going to be different between the autonomous system of IGP protocol. Next thing is it is an path vector protocol. Path vector routing protocol. What is the meaning of path vector? Anyone? It means, see, your IGP protocol like OSPF. OSPF sends what? With update message, prefix and link property. Link property means bandwidth, my cost, right? The information of link with prefix, right? EIGRP advertise key values with prefix so that my neighbor router can calculate the best path, can calculate the metric. But path vector routing protocol advertise what? Path attribute with prefixes. BGP is not going to advertise any information of link. It will advertise the link information of path with prefixes. Right? So here I can say router sends path attributes in their update message rather than advertising the link information. Link state routing protocol advertising metric means hop content, distance vector routing protocol, right? And k values in EIGRP. Done. For an example, here I have one router, let's say R1, and this router is connected with two different ISP router or my company router connected like this. BGP is, trust me guys, very interesting, very powerful routing protocol. I love BGP and I want you guys to learn like me, like how I learn the BGP. Then only you can troubleshoot the issues. Many engineers are struggling when they are troubleshooting BGP. 10.1.1.0/24 and here also 10.1.1.0/24. Here first of all tell me one thing, if I will run OSPF between all the router in same area, R1 will choose which path to reach in 10 subnet, R2, R3 or both. Bandwidth of link is same, cost is same, everything is same on default. Just I have connected routers like this. I have created one loopback on R2 and R3 with same IP address and I have advertised all the router, all the interfaces in OSPF, let's say. R1 will perform load balancing, right?
Balancing.
Load balancing, 100% load balancing. But if I will talk about the BGP, BGP does not perform load balancing by default. By default, BGP is going to select only one path. Either R2 will be the best next hop or R3 will be the best next hop. Only one path will be the best path. Even when everything looks same, when all the attributes are same, then also we'll see how. And here my BGP protocol will not advertise any link information. R2 and R3 will advertise these prefixes with path information, right? Like it will advertise the next hop IP address, R2 and R3 both. Next hop IP, it will advertise the ES number, it will advertise the local preference, etc. Right? These are the attributes which we will discuss, but R1 will select only one path. So all the path vector routing protocol advertise path information with prefixes in their update message. Best path selection is done with the help of path attribute. Let me write here. Best path selection is done based on path attribute. 11 types of attributes are there. We'll discuss those all. Path attributes is the best path selection criteria of BGP. Best path selection criteria of BGP. Then it is classless routing protocol. We all know this. No need to write. By default, automatic summarization is disabled, right? We can check it. And maximum path is configured as 1, right? That's why I told you it will not perform load balancing by default. Maximum path which is configured by default is 1. Only one path can be the best path. Means load balancing is not supported by BGP by default. After that, next point, it uses TCP port number. What is the port number of BGP? Port number 179. It uses TCP port number 179, and it is application layer protocol. Works at application layer. It means BGP is going to generate their all messages, whatever messages are there, update message, hello message, at which layer? At application layer, right? OSPF generates their all message, hello message, LS R, LSU, LSAC, DBD, all the messages at layer 3. Similarly, BGP is going to generate their all messages at layer 7, right? And it is completely reliable protocol, right? We have created BGP to be the slow protocol, right? We don't want BGP to be the fast like OSPF because we need stability. This is the best feature of BGP, not the issue. When someone is asking you why we will use BGP when we have OSPF, even BGP is the slow, OSPF is the faster than BGP. And why company will prefer BGP? So slow is the best feature of BGP. A stable protocol can't be fast, right? BGP should not take action when a small link is flap. When a small link flap is there. This is the reason. Okay. Now, if I will talk about the packet flow, so packet flow of BGP is going to be exactly same like your IGP protocols, but there will be TCP session R1 and R2. Let's suppose here I have enabled BGP on R1 and R2. Both the routers are not going to send BGP message directly, right? What will happen? Let's suppose router 1 have generated the BGP hello message, which is open message, by the way. Open message. At which layer? At application layer. Application layer will forward it to transport layer in TCP IP model, and transport layer can't send it directly because TCP connection will be established first, right? So transport layer will put this message on hold and it will generate what? SYN message. First SYN message will be exchanged between R1 and R2. SYN message. What will be the source port number? Random port number, let's say 1025. Destination port number, well-known port number of BGP, right? And now R2 is going to receive this SYN message. R2 will understand that, okay, R1 is going to use this port number 1025 and I will be using this port number 179. See, out of these two router, one router will use BGP well-known port number and one router will use any random port number. In my case, router 1 will reserve this port number 1025 for BGP, and router 2 is going to reserve 179 port number, right? Now they will exchange BGP messages on these two ports. R1 will send all the message of BGP on 179, R2 will send all the BGP message on 1025 port number. Is it clear?
Yes.
Right? So R2 is going to send SYN plus ACK message. In SYN plus ACK message, what will be the source port number? No problem, Rahul, just wait. SYN plus ACK, what will be the source port?
179.
179, and destination
179.
port 1025. Right? Router 1 will see, okay, destination port is 1025 and this port is reserved for BGP. Let me generate the acknowledgement, and finally it will send the acknowledgement on same port number 179. Port number, source port 1025, destination port 179. And now finally here we will have the TCP session. We will have TCP session, and now all the BGP messages will exchange over this TCP connection. Overall, right? Like your open message, or later we are going to learn all the messages of. That's why I'm saying BGP is a fully reliable protocol, because first, before sending any message, it will establish TCP connection. There are two AD values in the BGP. BGP uses two AD values. One is AD value. $20 and $200. 24 external BGP and 200 for
Internal.
internal BGP. Right? Now it means we have concept of external and internal BGP. External BGP is nothing but the eBGP. What we can say eBGP. eBGP means when you are running BGP between the autonomous system number. Let's say on auto number 1, AS number is 100, and on auto number 2, AS number is 200. 100 and 200, right? So this is eBGP. Here we will have eBGP neighborship, and on both the router, if autonomous system number is same, then iBGP neighborship, that is called internal, right? So both has a dedicated AD value like this, R1, R2, like this, R1, R2. R2 is connected with one LAN network 10.1.1.0/24, and copy paste. Right? Here my autonomous system number is 100. Here also my autonomous system number is 100. Here my autonomous system number is 100, but here my autonomous system number is 200. So in this case, R1 will use what AD value for 10 prefix, and R1
200.
here. Here we'll have iBGP neighborship. So AD value is going to be
200.
AD 200, and here we will have eBGP neighborship. So AD value is going to be 20. So you can also say like external BGP will be always prefer over internal, right? Like in this scenario, now if I'm asking you here, I have IBGP neighborship, and here I have EBGP neighborship. IBGP and EBGP. Now you tell me which path will be the best path. So now you can say, Praful, which one?
High BGP.
EBGP.
IBGP.
Now you can say next hop will be R3. Now you can say next hop will be R3 for 10. Submit. It is like that. So simple. Done. And you know all the TCP based protocol sends messages on unicast address, right? TCP based protocol can't send multicast message, right? So BGP is a unicast protocol. Like EIGRP or OSPF sends their messages on multicast. BGP is going to send their messages on unicast, right? R1 is going to send message R2 on the R2 IP address 12.1.1.2 or 12.1.1.1. Whatever IP you are going to define, misconfiguration is going to be a bit different. Like on R1, I will run this command router BGP 100, and then my command is going to be neighbor and neighbor IP address. If I am saying 12.1.1.2, so this will be the IP address, destination IP address in the BGP messages, right? Neighbor and then remote AS of neighbor as well. Remote AS. If I will say remote AS 100, router 1 will get to know that okay, my neighbor is IBGP neighbor, internal neighbor. If I am going to say remote AS 200, it will understand that my neighbor is EBGP. What AD value I should? Understood, guys?
Yes.
Okay, so that's why dynamic neighborship is not supported by BGP. Remember the use case of hello message in OSPF was what? DND and keep alive. DND means dynamic neighbor discovery and keep alive. But here dynamic neighbor discovery will not work. BGP does not support dynamic neighbor discovery. Doesn't support dynamic neighborship. Do you guys want me to discuss more about why BGP before starting BGP?
Yes, absolutely.
Yes.
Some more scenario on why first, because now I am ready to start the BGP. Okay, let me do some example.
Yes, sir, that would help.
Yeah, sure, understood. So see first where you will use the BGP, right? That will make you understand why as well. Where to use BGP only or BGP protocol. First of all, first scenario what I told you, between the company, or I can say when our organization is big, right? When we have large enterprise network, when our network is large enterprise network, because your all IGP protocol, I'm saying like a prox value, it is not like 1000, it can't be 1100. All IGP protocols handles around 1000 prefixes or less than 1000 prefixes. If you have more than 1000 prefixes in your company network, you will not prefer IGP, because IGP protocols are very fast. Quickly they change their behavior, they flap neighborship, they recalculate the best path. But we don't want that quick behavior of routing when we have lots of routes, because even one network will goes down or whenever it will come, all my routers are going to execute SPF algorithm in OSPF, right? So OSPF will work fine when you have a small network. Like disadvantage with a static route was what? The biggest disadvantage, It does not support dynamic failover. If primary path will goes down, manually we have to change the route. That was the biggest issue with the static routing. This is the reason why we started using dynamic routing protocols like OSPF. Their behavior is good. The dynamic behavior of selecting best path. But here when we have lots of prefixes, then we need a stable protocol, right? So whenever we have more than 1000 prefixes in our network, we'll configure IGP. Second, scenario number 2. Scenario number, IGP protocol can handle up to 1000 prefixes, okay? When we are service provider, when you are service provider engineer, will always configure BGP, because service provider are connecting multiple customers. Again, you will have huge number of routes, and there are some more scenarios that you will learn in upcoming classes in MP BGP. After BGP, we have again one more protocol, that is MP BGP, extension of BGP. MP BGP is the real hero behind service provider network. Because of MP BGP, only service providers are able to connect multiple customers, and they can isolate the prefixes. They can separate the prefixes of each and every customers. MP BGP. Here you will learn how your IGP protocols will not work. So when you are service provider, again you will configure BGP only. Third scenario, between company network, because here we will have different AS, and between the AS we can't configure IGP. We have to configure only BGP. Has only the feature of external neighborship between, yes, right? So between company network, between service provider network, between ISP, and fourth scenario can be ISP, when we are ISP, internet service provider, then also BGP. Because when you are ISP is going to install all public networks in their routing table, right? So size will be again, so between company, between provider, ISP, you will configure again BGP. It is like that. Let's suppose here I have one company. In this company some routers are there, R1, R2, R3, R4, R5, R6. All routers are connected like this. One ES, ring topology or full mesh topology. I had shown you the internet nodes. On the internet, you will find nodes like this. So this is one company, XYZ company, or one ISP. Yes, 100. Another company, yes, 100. ISP1 and ISP. Again here we have to configure what? Between these company I have to configure BGP routing protocol. To exchange the routes between the ISP1 and ISP, like Otherwise, even through redistribution, it is not possible to extend the route between ISP1 and ISP2. You have to add router, right? Like one router here, one router here, and in between you are going to configure any routing protocol. Here now IGP can work with lots of redistribution. That is not possible in production network. And to understand more about where to use BGP, you can understand the customer types. Like how many types of customers are there? Can anyone tell me how many customers are there? Customer type. Customer type means single homed customer, multi-homed customer, single multi-homed customer, dual multi-home customer. Types of customers. You are also one customer, right? If you are using the broadband internet connection, you are customer of ISP. Types of customers. Single homed customer. Can anyone tell me what is single home customer?
Just one link,
Just
no
one link
redundancy.
for
For
one
ISP.
From
application.
one
Yes,
ISP.
for ISP. And dual homed customer.
That has multiple connections from ISP.
Multiple connection from ISP.
Having
Single
Just guessing.
single multi-homed customer. And fourth one is dual multi homed customer. I think these are the only customers, right? So like if I will talk about the a small office network or your home internet connection, right? How you are going to connect lots of users and users through one centralized device switch. Now these all end devices can communicate with each other, but can they access internet? Can they access other side? No. So now I need to connect it to public network. I need one router here. This is my edge device. This router is my edge router. My edge router is connecting private and public network.
That works.
Can I use this network in the enterprise, the company? What is the issue in this network? Because everyone is using same network in home. In a small office also, you will find this one only. But
Single point of failure.
yeah, but I also have a small office and have the same setup. Why? Because we don't have any critical data in my LAN, in my network, right? That should be available 24/7. Even we have labs, right? For our SD-WAN students, those students are accessing our private lab. But if sometime, let's say for 5 minutes, internet is not working, we can tell to students, please wait for 5 to 10 minutes. After that, you can try. That means there is no any critical data, not business mission traffic is there. So this setup will work fine for me. And here we don't need BGP. BGP not required, right? Or you will access internet with the help of default route 0.0.0/0 ISP. Yes or no? Even I have configured default route on my edge router, which is connected with Airtel. I have, by the way, two ISP because I am taking live classes as well. Right? So in my home, there are two ISP. Sometimes if Airtel is not working because of bad weather, sometimes even it's happening like both ISPs are not working at the same time. At that time, we are canceling the classes. Don't have option. But imagine for company can't use this network. This is single home customer like me, customer like you. So single home customer don't need BGP protocol. Clear, guys?
Yes, sir.
So in this setup, in single home customer network, we don't need BGP. We will configure one default or towards internet and NAT. That is more than sufficient. Even if you need to configure VPN, you can configure. If you have same site somewhere else that is also connected with internet, you can configure VPN between edge to edge, R1 and R2. Because we have a single ISP, single router. What is the issue with this setup? Why I can't use this in company? Because what? What is the
No
issue?
redundancy.
Yes.
Yeah.
No redundancy. What if this link will fail, or this router will fail, or this WAN link will fail, or ISP will fail? Right? So now we have another types of customer network, that is dual homed customer. If I will talk about the dual home, again LAN side, you will be having same setup, right? Maybe you will have more switches, but at the edge device you have one router, and this router will be connected with two or more ISP.
ISP.
ISP1, and ISP ISP, and here I have 10
Router.
devices. Yes, right? Both sides you have public IP address. Let's say here my public IP address is 15.1.1, and here my public IP address is 16.1.1. Any public IP address. How you will configure internet access? Zero dot zero dot zero slash zero ISP
1.
1, and 0.0.0 slash 0 ISP
ISP 2.
2, AD value 10, higher AD
10.
value. Right? This is the way to access, and then finally PAT, port address translation for internet access, for private to public translation. But in this setup, if you want load balancing, this particular thing is called conditional default route. Here, if you want to use load balancing, then you have to configure BGP. Even this is our lab. In the class, we will configure this. Our lab, that how a simple default route can't load balance the traffic between ISP1 and ISP2, and how BGP can solve the issue. Still, what is the issue in dual homed customer network? For ISP, now we have redundancy, but for router, we don't have
Backup.
redundancy. Yes.
Redundancy.
So companies, a small company can use this setup, but again, enterprises, data center, headquarter, right, or large companies will not use. At least you will have two edge devices here for load balancing, load sharing, right, for active backup, primary, secondary, like that. So that setup is going to be single multi-homed. This setup is called
Dual homed.
dual homed customer network. This is actually not dual homed customer network. This is single multi-homed customer network. Actually, I forget to mention this dual homed customer network. Let me write here. This is third types of customer network, which is dual homed customer, single multi-homed customer network. In dual multi-home customer network, you will have one router and you will have two WAN link with same service provider. This one, like this, will have WAN link like from the same service provider to WAN link. You can configure traffic sharing, right, through BGP. Again, here you will use BGP protocol. BGP in dual homed customer network also and single multi-homed customer network also, right? And if I will talk about the actual enterprise setup, so they will have at least two edge device and at least two ISP, and then LAN devices, and they will connect. Works like sir. Here also you will configure which routing protocol? WAN side. Right. When I am saying BGP in this setup, it doesn't mean BGP only for default route, right? BGP to receive route of other sites as well, like my data center is also connected with ISP, another ISP. So we will be receiving route through those other sites through BGP routing protocol, right? Load balancing for data center prefixes, right? So in the customer network here, my BGP, here also my BGP, right? In dual homed customer network, you can also configure static route, and sometimes you will find that. But single homed customer and single multi-homed customer or dual multi-home customer, you will always find BGP routing protocol. These are different types of customers, right? So here also we can see the needs of BGP. Then let's suppose router 1, router 2, router 3 and router 4. Same network. Here I have some subnet 10.1.1.0/24. And let's suppose we are running OSPF routing protocol here. Which routing protocol? OSPF here. And here. And here we are running what? BGP. And here I have another subnet 20.1.1.0/24. Not BGP, let me say EIGRP. So can 10 and 20 communicate here? Can 10 and 20 communicate? Can 10.1.1 and 20.1.1 communicate after configuring the routing protocols? No.
No, it shouldn't.
Not without redistribution.
On this router,
No.
you have to redistribute OSPF into
Yeah, GRP.
EIGRP, OSPF into EIGRP, and here on this router,
Yeah, GRP into OSPF.
EIGRP into OSPF. This was my OSPF domain, right? R1 was advertising 10 subnet to R2, and again R3 is advertising same prefixes in OSPF domain. This is what? If there is no
Yeah.
any connectivity or any other routing protocol is running between router 1 and 2, it can have loop. So redistribution fail here, right? Redistribution has n number of issues. One common issue is creating long database, big size of database. It will consume lots of memories. Configuration is going to be complex. But the most critical and bad thing of redistribution is routing loops. Because of even a small mistake, there can be loop, routing loop, and it can reduce the performance. Because loop can increase what? CPU, and CPU is inversely proportional to performance. As CPU will increase, performance will start getting reduced. So doesn't matter what is the ES number here, what is the ES number here, we can configure BGP, and redistribution is not required. Best example can be this way, like service provider network. Let's suppose this is service provider, and this service provider has some routers R1, R2, R3 and R4. Later you will learn in service provider network we have two types of router, PE router and P router, provider edge and provider router. P router are the edge router, right? Like here this router is the P router, P1, because here I will connect the customer. Now I am assuming this router is connecting customer A and customer B. Customer A and customer, and like this provider edge router, P router, connecting many other customers as well. If each customers are using their own routing protocol, each router are using their own routing protocol, then lots of redistribution is required on this P router, isn't it? Because P to P, you will always configure MP BGP, right? You will see here I will have one session between P to P to advertise the prefixes, that is MP BGP. Don't worry if anyone is not able to understand, because we will learn these all things upcoming classes. Here you will have MP BGP. So MP BGP you will advertise. This is like global session between P to P, which will carry customer A prefixes as well as customer B prefixes. And if customer A is using, let's say, OSPF, so provider need to redistribute OSPF into BGP first, right? If customer B is using EIGRP, again provider A need to redistribute EIGRP into BGP, and then BGP into EIGRP and OSPF as well. To avoid this kind of redistribution, customer and provider, between customer network and service provider edge router, you will configure BGP only, right? BGP can only avoid redistribution. So here also we will configure BGP inside the service provider network as well as between customer and service provider network. And for reachability between P to P, like P1, this is P1 and this is PE, they can only configure MP BGP. This particular thing is also called as L3 VPN. MPLS L3 VPN. Later you will learn it, right? So MPLS L3 VPN can be only configured between P1 and P2 if both are reachable. If both are reachable. And for the reachability, service providers are also going to use IGP protocol, because here we need fast protocol, quick action taking protocols, right? So they will use OSPF. We are not going to use BGP only. We are not going to use OSPF only. In the production, we will use in mix of OSPF plus BGP. Many time, more than 80% scenario will have OSPF as a underlay protocol and BGP as a overlay protocol. And trust me, when we will be learning more about the BGP, you will learn many other reason of using BGP as well. Till now, we have talked about the what IGP issues, like IGP works with connected device only. We talked about the stability, the meaning of stability, right? We talked that if IGP protocols like OSPF, PAGRP can handle 1000 prefixes only, but internet has billions of routes. So IGP protocols are not designed to handle millions of routes. We have to use only BGP. OSPF can't handle that many prefixes, and even OSPF floods LSAs, right? And it calculates SPF again and again whenever change will occur. And when my network is large, when we have huge amount of networks, then OSPF can't be worked properly, because if OSPF is going to execute the SPF algorithm again and again, it can increase again the CPU, and CPU will reduce the performance, right? And BGP is the incredible protocol to manage huge amount of prefixes. It is like, guys, if I will give you one more example, real-time example. Say, tell me one thing. If you need to travel within the city, right? You need to go to market and to purchase milk, right? Within the city, you need to travel within city, and you have two types of vehicle. You have bike and car. Which one you will prefer? Which one?
Sorry, bike.
You will prefer bike. Why? Because very easily we can turn left, turn right in the city, within the city. Bike is the best
Best choice.
vehicle within the. But if you need to travel between the city, let's suppose you need to travel 500 kilometers through highway. Will you prefer bike? Is bike stable for long distance travel over highway? No. Bike is not stable, right? Then you will prefer what? Car. BGP is like the truck which carry high load and travel long distance on the long highway. So within the city, we need fast, quick decision taker routing protocol. Between the city, between the countries, we need a stable protocol like BGP. Hope this is more than sufficient about why BGP only, because from last around 1 hour we are talking on why only.
Sir,
Right?
in this diagram, we're running, you said MP BGP between PE to PE.
Okay.
And then within the service provider network, we have underlay of IGP.
Correct?
Is that what you said?
Yes, exactly.
So underlay is IGP and then overlay is MP BGP.
Now for global routing table, you can say MPBGP, and for internal reachability between P2P, you can say OSPF.
Okay.
Praphul, I just wanted to go back
BGP
to
is not a network. That was an example. BGP is a routing protocol. Overlay, when you are saying overlay, it means we are talking about the network like VPN. VPN is a virtual network, right? It is similar like that. Yes, go ahead.
Yes, when you went to the customers, not the home, I think it's a situation. You had 4 scenarios. If you could go back a little bit.
Yes.
The difference between number 2 and number 4. It's not too clear. No, go to your left. No, your left. And if you can go up a little bit, yes. The difference between number 2 and number 4.
Number 2.
And number
When we are
4.
service provider.
Where? Okay.
When we are service provider here, this network between P1 and P2.
Yes.
We will
And then you
configure
said,
BGP.
also said, okay, then the number 4.
Number 4 is the when we are internet service provider, ISP. ISP has lots of routes. ISP router will have lots of prefixes in their routing table that can't be handled by IGP. SP and ISP both are different. SP is service provider who provide you the connectivity between two sites. And ISP are the internet service provider which provide you the reachability to public IP address. Yes,
I know I'm confused because now then what is the difference between 2 and 3? If you say service provider, can you clarify?
Huh? Between 2 and 3. When we are service provider like this, let's say this is Airtel, and similarly one more service provider is there, that is Jio or Tata. So between the Tata and Airtel, we will configure BGP.
So is Airtel not an ISP?
Sorry?
Is Airtel not an ISP?
Service provider and ISP are the same thing.
Airtel is ISP as well as SP.
Okay, because I'm trying to understand the difference between point 2 and then point 4, those situations.
Yeah. So Airtel is ISP as well as SP. It can give you the MPLS connection also to connect two branches, and it can give you the internet as well.
Oh, okay. So so now okay, I get you now. So the company that provides you the connection between your sites and then okay, and I'll get it. It's clearer. Thank you.
In the ISP network, BGP. In the service provider network, BGP. In the service provider, also IGP. Between the company, BGP. When we have dual home customer network, BGP. Single multi-home customer network, BGP. Dual multi-home customer network, BGP. When my enterprise network is large, then also now if you guys are clear with why, then I will start BGP with a very basic lab of 2 routers. Can I configure BGP here to understand few more things? BGP
Yes, please.
100, BGP S number 100, and BGP number, let's say 100. R1, R2. Let me configure the IP addresses first very quickly, and then we'll implement the BGP. And before implementing the BGP, I would like to capture the interface F0/0, no shutdown, and IP address 12.1.1, 255.255.255.0 exit. Go to R2 and BGP router ID concept is exactly same like BGP OSPF router ID. Okay, so higher loopback IP address will become BGP router ID. If loopback does not exist, then
hierarchy.
highest
Physical.
physical interface IP address, and you can configure manually on router number 1. If I am going to ping router 2, 12.1.2, you can see ping is working. Yes, ping is working. Let me capture the link and let me configure the here. I am not going to advertise any network for now, just I am forming BGP neighborship between R1 and R. So router BGP ES number 100. This command will only allocate some memory to the BGP routing protocol. That's it. Right now it is not sending any message of BGP. Debug BGP, and all I can say VPN v4 is the address family which we will discuss in MP BGP. For now, even we are not talking about IPv6, we are talking about IPv4 address family, and we will discuss address family as well. Address family is types of networks like your IPv4 network, IPv6 network, VPN v4 network, IPX network, Apple Talk, like that. So debug, I think IPBGP, and then question mark. Here I can find the BGP messages. Update message is there. All is there for all address family. I can say event. Let me say event. Okay. So IP protocol. Now you can see routing protocol is BGPS number 100. No filtering in outgoing direction. No any filtering for incoming. Update message. IGP synchronization is disabled. We'll talk about this later. Automatic summarization is disabled. You already know this. Maximum path is 1. We have already discussed. And distance you can see for external 20 and for internal 10. Let me disable the debug. Traffic. Router BGP number 100 again. And I can say BGP router ID. Manually I can configure router ID 1.1.1, and on router number 2 router BGP 200 and BGP router ID 2.2.2. Right now routers are not sending any hello message. You can see in the capturing because I didn't enable BGP on the interface. Guys, how you were enabling OSPF here? How you will enable OSPF between router 1 and router 2? With the help of network command. As soon as you will enable OSPF on this interface, it will start sending hello message, right?
Hello message.
But for BGP, you don't need to advertise this 2L network into the BGP. Here I need to define neighbor command, neighbor and 12.1.1.2.
True.
And remote AS of neighbor is 200. Now what will happen? Router 1 will start sending first message of BGP, which is open message. To understand the open message of BGP, it's very simple. Tell me the use case of hello message.
To discover the neighbor and the keep
Yes.
live messages.
Neighborship and keep alive. Here in
Keep
BGP,
alive.
open message is only used for neighborship.
Neighborship.
And for keep alive, we have a dedicated message called keep alive.
Keep alive
BGP
message.
have as a message called keep alive, right? So open message is only going to form the neighborship. Now, as soon as I will hit enter here, and you can see in the capturing, it should start sending open message. But is there any open message?
Not yet.
Not yet. So how can I check the port number? Which port number is enabled on the router? So control plane.
Yes. So
Control plane
connections.
host open port number, right? Yes. So you can see port number 179 is enabled, and this router is listening on this port. Service is BGP,
BGP. In
right?
BGP
So
in listening state.
yeah, this port number is in not BGP neighbor. This is not BGP neighbor in listening
So this
state or
is the
active state. This is port, TCP port number. It is listening on two port number,
BGP.
telnet and BGP, because I have enabled the BGP.
Okay.
And here you can see we don't have any open message, but there is one TCP SYN message. TCP SYN message.
Sin.
In the TCP SYN message, source IP address is the 12.1 and destination IP address is the IP address of neighbor. Right here I run command neighbor 12.1.1.2. So router 1 is going to find the route first for to reach neighbor. So IP route 12.1.1.2, 12.1.1.2, and the exit interface IP address will become what? Source IP address. Now it is not mandatory that my neighbor is directly connected. Doesn't mean it is connected or not connected. Route should be there in the routing table so that it can send TCP SYN message. And route is already there. You can see exit interface is F0/0 and IP address which is running on F0/0 is
12.1.
12.1. So source IP 12.1, destination IP 12. Very important to troubleshoot BGP neighborship. Right now on router we don't have any TCP connection. So TCP brief don't have any TCP connection. If you are going to telnet R2 from R1, you will have first one TCP session because telnet uses TCP. Similarly, R1 is sending SYN message, but we don't have TCP connection. Why? R2 is declining. Why R2 is sending reset message? You can see reset and acknowledgement coming from 12.2, source 12.1. When any device, router or server send reset message, TCP reset message, when the port number is not enabled, right? Like right now, what is happening here? R1 is sending one TCP SYN message, TCP SYN with source port number, any random port number, destination port number 179, right? And R2 will receive it. R2 is going to receive it at layer 1, then it will check layer 2 information, means destination MAC. Destination MAC will match with receiving interface. It is going to check layer 3 information. Layer 3 information is destination IP 12.2. It is still matching. It is going to check layer 4 information. Layer 4 information means port number, destination port number 179, and 179 port number is not enabled on router 2. So control plane host open port number. So when you are running command router BGP and AS number 100, this command is not going to open. Port number means BGP is not enabled. When you will define the neighbor command, then it is going to start listening on BGP well known port number, which is 179. That's why from R2 reset message is coming. Very good. Now on router number 2 also I am going to say your neighbor. What happened? We don't have any SYN message from R2 because port number is not enabled, and that's why you can see only TCP message. R1 is trying to establish TCP connection again and again. Done. On router 1 console, you can debug TCP to see the TCP message. Not important. Go to router 2 and let me configure neighbor command here. Router BGP AS number 200 and neighbor 12.1.1 and remote AS. See, this is not the router ID of neighbor. This is the IP. Router ID is not reachable, right? Not reachable IP. Router ID is the identity. I am defining the IP address of router. Remote AS 100. Now So open control port. Now you can see 179 port number is open on router number 2 also. That's why router 1 has here the SYN message, and then router 2 have generated reset. Where is the next SYN message? Here it is, the final last SYN. R1 is sending on which port number? 25919. Now remember, this port number is reserved on R1. Until and unless the BGP session is not going to synchronize or break, R1 will be using this port number. Here also you can see same port number. And if I will show you the BGP message, then after SYN message of R1, here is the SYN message of R2 and acknowledgement message, and then finally acknowledgement message of R1, and all are unicast message, and here is the first message of your B, right? Here on the console you can see the log message of BGP neighbor 12.1 is up, very good. On router number 1, neighbor 12.2 is up. Here is your first message of BGP open message used to establish neighborship. If I will open it, here you can see your message is at application layer, and inside the open message ES number information is there, hold on time is there, BGP router ID information is there, and some additional parameters are there which are not important, nothing important. Route refresh capability, you will learn this, don't worry. Then we have TCP header, IP header, and Ethernet header. So simple. Now we have BGP session, but before BGP session, here we have what? TCP connection on R1. If I am going to run command now, so TCP brief, then here you can see the TCP connection with session ID, this one, and this is the port number of 12.1, and this is the port number of 12. R1 will be using now this port number, R2 will be using this well known port. Is it clear, Rahul, now?
Sir, 25919 is reserved for this.
No, this is random. Source port number. R1 has used this random port number as a source. BGP has only one port number, that will be the destination port. If R2 is going to start sending open message, then maybe R2 will use random port number and R1 will use well known port number. Any one router will use well known and other will use random. The router who is going to receive open message first, not open, sorry, extremely sorry, the SYN message first will be using the well known port number. In this case, R2 have received the SYN message first from R1. That's why R2 is using well known port number. See in this SYN message, R1 is sending first SYN message, source port random, destination port well known, right? So R2 has started using the well known port number, and R1 started using this port number. Otherwise, every time port number was getting changed, you can see when R2 was sending reset message, because every time R1 will try to establish TCP session with new port number, right? It's like that. Again, if I will clear my BGP session, if I'm going to say clear IP BGP and now you can see SYN message of R1 port number. Now port number is changed,
Yes.
right? This is the finish message to terminate the connection. Here is the first SYN message. Now port number is changed. Now R1 is going to use another random port number. This is not well known. Port number will get changed. And how we can verify the port number? So TCP brief, that which router is using which port number. Here you can see the port number of This session is established. Right? These are old entry. So it will remove. Right? Here is the port number of your R1. Here is the port number of R2. And so IP BGP summary. Here I can see the neighbor SIP. Now in the neighbor SIP, understand neighbor IP address 12.1.1.2. BGP version 4, neighbor AS number is 200, received message from this neighbor is 16, send message to this neighbor is 16, leave it for now, leave it now, leave it now. This neighbor is up from last 27 seconds and received prefix is 0. Guys, I have not advertised 12 network into BGP. Is it possible in IGP protocol to not advertise this network which is running on this segment in the routing protocol and having neighborship? Not possible, right? Not possible. We have not advertised 12 network into the BGP. If I will show you the BGP table, so IP BGP, which is the similar like OSPF database, you can see it's null. Nothing is here. And even you can check the neighbor information in detail, like my router ID is 12.1.1, my local remote AS is 100, and the neighbor information. If you want to check the detailed information of neighbor, you can run command show IP BGP neighbor, and then you can define the IP address of your neighbor, or like this. If multiple neighbors are there, then you can run this command. See, the detailed information of neighbor is here, very important. What it's saying? My command BGP neighbor is 12.2, remote AS 200, link is external, means eBGP. Right? In so IP BGP, can I verify that? We can verify that, but external or internal is not mentioned there. And router ID of neighbor is 2.2.2. State is established up from last 2 minutes and 0.6 seconds. Right? Keep alive. It is information about the timer. Hold on time 180 seconds. Keep alive 60 seconds. OSPF is sending hello message after every 10 seconds. BGP is sending very small message as compared to OSPF hello message. That is keep alive message. Even in every 60 seconds. It is sure that BGP is not fast. It is very slow protocol. And as it is slow, can be right. The neighbor capability, we'll talk about this. Here you can see the send and receive messages, right? How many open messages are exchanged or send and receive? 3. How many notification message? 0. Later we will learn what is notification message. Update message? 0. Keep alive message? 15. Route refresh message? 0. You have understood that we have total 5 types of messages in BGP. Total we have 5 types of messages in BGP. Open message, notification, keep alive, update, and route refresh. We will learn each types of messages in detail, and total exchanged message you can see send and receive is 18 and 18. Very good. Now on R1 I am going to create one loop back interface, loop back 1 IP address 10.1.1.1 255.255.255.0. Done. Very good. Router BGP 100 and network 10.0.0.0 mask 255.0.0.0. Tell me, will BGP advertise 10 network in BGP? Will I have 10 submit in BGP table? Interview question.
No,
Why?
because not configure auto summarization.
Okay. In OSPF, if I am running OSPF and like this, if I will advertise, will it work? If automatic summarization is disabled or enabled, doesn't matter. in both case? Yes, it will work in both. But in BGP, it will not work. See, understand, BGP will only advertise prefixes if same prefix with same subnet length is present in the local routing table. OSPF can only advertise those prefixes which are connected on router, but BGP can advertise any prefix which is present in local routing table, but subnet mask or subnet length should same, right? So here you have to advertise BGP with same subnet mask, router BGP 100, and I am saying no to this, right? Because in my local routing table, so IP route, in my local routing table, this network is present with /24, right? So let me say network and 10.1.1.0 and mask 255.255.255.0. Very good. So IP BGP, and now you can see in the BGP we have prefix. Now R1 is going to send update message. Are you able to see the update message from R1? Yes. Let me open. Again, you can see source port number same, destination port same, source MAC, destination MAC, source IP, destination IP exactly same, like open message. And in the update message, this time it is sharing NLRI. BGP advertise or exchange NLRI, network layer reachability information. Prefixes or routes are called as NLRI in BGP, right? If I will open NLRI, you will find the prefix your network 10.1.1.0. Only two things were full: network and subnet mask. How router 2 is going to calculate the metric? Here is the main field, which is attributes. You can see path attributes. Along with NLRI, it is advertising path attribute, and in the path attribute you can see origin code, AS path, next hop, and MAC. We will talk about all. And now finally, after sending update message, router 2 is acknowledging. Router 2 will send acknowledgement because it is reliable protocol. Update, then acknowledge. Great. Now here let me show you in the CLI. In the CLI, show the BGP table, which is similar like the routing table. There are so many things here, like incomplete, eBGP, iBGP. Sometime you will see BGP routes present in the database but not in routing table, because BGP route can be best, not valid. Sometimes it can be valid but not best. And BGP only use or advertise the prefixes which are valid as well as best, right? So valid symbol is a star and best symbol is greater than sign. This prefix is valid as well as best. Valid as well as best. Network 10.1.0/24, and next hop IP is 0.0.0. What it mean? It means this is self-advertised prefix. If interviewer will ask you how to check self-advertised prefix in BGP,
Next hop IP 0.0.
next hop IP for self-advertised prefix will be 0.0.0. Let me take you to R2 and let me show you the BGP table here. So IP BGP. Again here the prefix is valid as well as best, and next hop IP address is 12.1. How router 2 have calculated this next hop? So source IP address in the update message were full. Source IP became next hop on R, right? And here you can see the attribute. These are attributes. We'll learn it, discuss it, go in deep. If you will open this route in detail, so IP BGP 10.1.1.0, now you can see the detailed information, right? Here you can see coming from the update message coming from 12.1, that become my source. Router ID of advertiser is 1.1.1, and attributes here. Local preference matrix is 0, valid bit is on, external bit is on, and best bit is also on, right? And as this is valid as well as best, it will install it in routing table. So IP route BGP, very good, and AD value is 20. Now I am going to add one more router here on R2. Let me say R3, and see the interesting thing. Now I am going to configure R2 and R3 and neighborship between R2 and R. Config T interface F0/1 no shutdown. IP address is going to be 23.1.2.255.255.255.0, and a router BGP AS number 200. Or let me do one thing here. Let me replace the ES number 100. I am going to configure number 100 for now. Tomorrow will that scenario as no router BGP AS number 200, and on R1 also I have to modify router BGP 100 and no neighbor 12.1.2 and remote AS 200. Now I have to say neighbor 12.1.2 and remote AS 100. Right, go to R2, router BGP AS number 100, neighbor 12.1.1 and remote AS 100, and neighbor 23.1.1.3 remote AS 100, and BGP router ID 2.2.2. Why we don't have neighborship here? What happened? Remote AS 100. So IP summary. Okay, now you can see we have neighbor, two neighbor, one neighbor is active and 12.1 is up, and it is receiving one prefix from this neighbor as well. Receive route 1, and that route is valid as well as best. Again same thing. Now this network is not best, only valid. Soon it will become best. Just wait for some time. Okay. Now let me take you to R3. Till then, let me configure R3 interface F0 shutdown and IP address 23.1.3 255.255.255.0 exit router BGP number 100, and I am saying BGP router ID 3.3.3.3 3.3.3 and neighbor 23.1.2 and remote AS 100. So IP BGP summary. Neighborship is still in active state. Ping 23.1. Ping is working. So TCP brief. No TCP connection. So run section BGP. Router BGP 100 and router ID. Okay, now neighborship is up. So IP summary or brief. You can see the port number. R3 is using well-known port number and R2 is using random port number. So IP. Here you can see we don't have 10 subnet on R2. So IP BGP. Now prefix is valid as well as best. R2 is going to install it in their routing table. IP. Great. But R2 is not advertising this network to R3.
Here AS number is 200, I think.
No, there is no any issue. It's fine. Everything is working fine. This is the behavior of BGP. It will not work. This is loop avoidance mechanism. So I want 10 network on R2 as well as on R3. So I can form neighborship between R1 and R3 as well, right? I'm going to say router BGP 100 and neighbor. This is IBGP full mesh. Neighbor 12.1.1.1 and remote AS 100, and on R1 neighbor 23.1.1.3 and remote AS 100. Can we have BGP neighborship between router 1 and 3? If not, then tell me the reason. I am saying no, neighborship will not come up. Now you need to tell me why. Just think and then tell me.
We need to have reachability.
Yes,
between
reachability is
router
not
one
there, right? What happened here? I have defined the neighbor 23.3. Router 1 is going to look up route. So IP route 23.1.3 to reach neighbor and network node in table. So what you will do? You can configure IP OSPF1 area 0 R2 interface range F 0/0 and F 0/1 IP OSPF1 area 0. For reachability, I am running what? IGP interface F 0/0 IP OSPF1 area 0. Now we will have neighborship. Now if you will check the routing table, so IP route and 23.3 network is still not there. So IP protocol OSPF is enabled. So IP OSPF neighbor is in extra charge. Just wait for yeah. Now neighborship is in full state. Let me check the routing table. Now route is there and so IP BGP summary. Now I am expecting 2 neighbor and you can see both the neighbors are up. Receive route 00. 10 is there on R1. 10 submit 10.1.1.0 on R2. So IP OSPF database. Here we have router LSA of R1. Router LSA of R1. And how many links are there? Only one link. It's 10 submit coming through OSPF, guys. No. 10 subnet is not coming through OSPF. 10 is coming through BGP only. And on R3 also. So IP OSPF database. In the OSPF, you will not find 10 subnet 10.1.1.0. This is router ID of R1, not prefix. Right? So IP route. In the routing table, you can see 10 subnet is reachable through BGP protocol. Why we are running OSPF here? For internal reachability only. OSPF, in OSPF, we have only 2 subnets. These 2, that's it. To advertise the prefixes, we have BGP. Now, if I want to advertise lakhs of prefixes between R1 and R3, I can. OSPF, no need to handle those prefixes, right? I will not advertise that in OSPF. I have configured OSPF so that my BGP session can be up between router 1 and router number 3. From here, we'll continue in next class. Just this was the basic of BGP. Tomorrow class is going to be really very interesting and very important because tomorrow we will learn many concepts of BGP which we are using in the production. That's all from my side for today. Now if you have any question, please ask. Yes, one by one.
Sir, here why OSPF is required?
To make reachability. Reachability, sir. What you said on router number 1 in BGP, your neighbor is 23.3. So route should be there, na? To reach, to send TCP SYN message to 23.3. If you don't want to configure OSPF, you can define a static route. Neighbor IP address should be reachable. Yes.
For the reachability, I can take EIGRP also.
Yes, you can take EIGRP also. Any routing protocol will work.
So what is the meaning of maximum path limit 1?
Means it can store only one path in the routing table for one destination.
Okay.
So if you have a router 4 also, R1 interface will have BGP, R4 also have a BGP. In between R2 and R3 also we need reachability.
Exactly.
The two OSPF, OSPS both are. If it's one
Yes.
OSPF, other one is different protocol, it won't work, right? Okay.
And this is loop avoidance mechanism of BGP, that like when router 1 is going to advertise 10 subnet to router number 2, it will not advertise to R3. Right? Same thing was happening. Because of that, on R3, we were not receiving 10 submit, but now so IP BGP we are receiving 10 submit. And next hop IP address is still what on R3? 12.1. Because source IP address in the update will be 12.1. This update is not coming from R2, it is coming from R1. Right? So when you will configure this, you can experience and explore all things. In the capturing also you can
Sir, even I have reachability if I do not advertise manually. They will not be BGP between router 3 and router 1.
router 3, router 1.
Even I have reachability if I do not make the neighbor, they do not share or make connections.
What? What's your question?
It's not question, but to if I am getting it right.
Yeah, what I am saying, when I am defining the neighbor IP address in the neighbor command, so there should be route for to reach that neighbor. Route should be there. For that I have configured IGP. Even when I will configure one default route on router number 1 towards R2 and one default route on R3 towards R2, then also 12.1 and 23.3 can ping. But default route will not work for BGP neighborship. Again, your BGP neighborship will be down. Down. Knows that default route will not, right? So reachability is not the only thing, right? Routes in local routing table for the neighbor IP address must be there. Then only BGP neighborship will. And loop avoidance mechanism is whenever you are receiving a route from your IBGP neighbor, do not advertise it to other IBGP. 10.1.1.0/20. R1 will advertise it to R2. R2 is receiving it from IBGP neighbor, so it will not advertise to other IBGP. But that's why you need to configure full mesh IBGP here. R1 has two neighborship with R2 as well as R.
So we have to advertise manually to
What?
every router we want to have the 10 dot subnet.
What you have to advertise manually
10 subnet.
in BGP?
Yes.
Yes. You have to advertise it manually.